girls, question 1. It says the area of a rectangle is to be 50 square meters. So we're given this diagram here. And we've got these dimensions, and it says the area is this. The question is, given this information, show that the perimeter of this rectangle is this. All right? So in order to do these type of problems, work with what you're given first. We've got this. So the area is 50. But what's the area in terms of the dimensions given? Yeah? Length times breadth of a rectangle. So we've got this. Let's work with this. We want to get to this. Before we do that, also, what's the perimeter of this rectangle given those dimensions? Yeah, 2x plus 2y. So here's my setup. Basically, we want to get from this and then substitute it in here because the question is to find perimeter in terms of x's. As you can see, it's all in terms of x. So what should I make the subject of in this particular formula that we have? Should I make x the subject or y the subject? Y. We want to make the y the subject. That's right. So then y is equal to 50 over x. Substitute that because that's the y. Sub it in here. And can you see the answer for me? 2 times that is that. So there you go. We've done the first question. The reason why you got to be able to do this type of problem is next lesson is finding the minimum or the maximum perimeter of a rectangle given in this situation. So you know how we've been finding minimum and maximum points on the curve? It's also applicable in different contexts. We can also use it to find minimum or maximum profit of a business, minimum or maximum area or surface area of a volume of a certain solid. It's used in a variety of contexts, and that's what we're doing today, deriving the formula to be actually find those things. All right, so let's apply the... Okay, show that the area of this paddock is, so we need to show that the area is 60x minus x squared. All right, so that's all we're given. They want everything in terms of x's. So what you want to do is by labeling one of the lengths of a rectangle with x. Let's just say that's x. That could have been x, it doesn't matter. If that's x, this is x. Yep? Now with this one though, let's call it y because we also don't know that. So we've got 2 letters right now. Leave the x's alone because that's what we want, but we need to figure out what this y is. Given the perimeter is 120, how would I find y? Because girls, what's my current perimeter with the letters that I have? Yeah? So let's replace it. I've got 120. I've got the 2x. Now from here, I'm trying to make y the subject, aren't I? I'm trying to figure out the equation for y. So I can find the area, which is xy. My question is to find the area in that term. And the area of a rectangle is xy. So once we figure out the equation for y, let's see what we get. So from here, if I make y the subject, so I get this, divide the 2. So I have that. So my area of a rectangle is xy. So in this case, my x is there and my y is? And that's that. As required. Okay? So that's kind of how you do it. I can't give you like step by step. It's just like you just kind of mix and match to a variety of things. Yeah. A closed cylinder is to have a volume of 400. So I'm going to write that down. Everything that I read, I'm going to write up on the board. And then it says show that the surface area S is 2 pi r squared plus 800 over r. So once you have these written down, you want to write down the formulas that you know. With the volume, we know the volume formula of a closed cylinder is? Yeah, girls, these are year 9 and 10 formulas you got to memorize. Yeah? I think some of mine. Check it out. I'm not sure. Girls, what should I do from here? I think it's good for me to ask you what the next step might be. You want to... Sorry? You want to keep replacing the numbers and the letters as much as you can. We got this. What do we know about this from here? That's right. So replace the letters with the things you know. Okay, now we got that. Another thing that I should have written. We know the volume formula, but what else do we know? We also know the surface area of a cylinder in generic form, which is 2 circles on top and bottom plus the curved surface part. So write down the generic formulas you know as well as the given formulas. So, girls, we want to get to the S formula. Having a look at this, it's all in terms of R. So from here, I don't want the H. So that means from here, I want to make H the subject. That's how you work it out. Yeah. And then basically sub that in there. I'll let you girls do that on your own. I don't want to give out too much. That's how you get that.
That's so smart.
All right. Now, question 5. I actually had to make a few PowerPoint for question 5 and I think 9, just to give you a context. Because Nabia, you asked me a good question. This motivated me to make this. So a 30 centimeter length of wire is cut into 2 pieces. Okay? Basically, the first question is, oh, sorry, I forgot to also say, from this part of the wire, you're going to form a square. And from this part of the wire, you're going to form another square. The question is,
Why is the wire? So take the X part and make it into a square.
So girls, I know a lot of you girls might have confusion about this. So this is what they mean. Let's take the X part. This is what they're doing. Girls, looking at the PowerPoint here. Like that. Does that make sense? So that's my X. You're literally getting the Y and you're bending it into 4 equal sides. So my question to you is, in order to actually do the problem, what is that length there? Good, that's right. So that means this is also X over 4. So that means, oh sorry, the first part's very easy. Why is Y equal to 30 minus X? Well, it's pretty straightforward. That is literally 30 take away X. So you just literally need to say, well, you can just say X plus Y equals to 30. So then you could write Y equals 30 minus X. That's the easy part. So I just skipped the question because it was so easy. Question B is show that the area. So girls, let's call this area 1. What's that area? Girls, side times side? Good. Similarly, just based on what I've shown you, that would be Y over 4, but we know the expression for Y. So then this would be 30 minus X over 4. Does that make sense? Yes. So then the area 2 would be, correct? And then how would I find the total area? I'm not going to do the algebra work, but this is my guide for you girls. That will get you the result that they want you to find. Okay? Question 7, please. All right. This one's a bit tricky, so I did also make an animation. A 10 by 7 rectangular piece, as you can see up here, has equal square corners with side X centimeters cut out. So what they're saying is, it's cut out like that. Yeah? So the dotted line there, they cut it out. All right? Now, from here, girls, the sides are folded up to make an open box as shown. So can you see when you fold that up, it creates a box? Sure. Yeah, so it's like folded up, folded. Yeah? So, girls, here's the question. They want you to show that the volume formula is that long equation there. So, girls, before we do this, what is the volume formula of any general rectangular? Yeah, so what we need to do is get an expression for those lengths. All right, So let's do it. Girls, just a tip. This is important for you to know. This is important for you to know before I move on. If that's x, that's also x. Can we agree on that for now? It's a square, so it's got x lengths everywhere. Now, here's my question. What's that length? 10 minus 2x, not just 10 minus x, because if it's x there, you've got another x there. How about that? That's why it's getting recorded. Oh yeah, I'll put it up if you want. Yeah, 7 minus 2x. Good. So, because x there, x there. Now, let's put that aside. We've got this box. What's that length at the bottom?
7 minus 2x.
You sure? Oh, it does. It depends on how you look at it. That's fine. Same thing. That's x, and that is 7 minus 2x. So basically, if you multiply all those three, you get the answer. It's stuff like this that's hard to actually get if you can't visualize what's happening. All right. Last question, question 9. You're going to need it. Good question from you again. Joe is 700 kilometers up north. I'm just reading the question here. And he's traveling towards it. Girls, Joe is traveling towards the town at 75 kilometers per hour. Nick is here and is traveling towards the town 80 kilometers per hour. So, girls, show that after t hours, so after a certain amount of hours, the distance between Joe and Nick, D, is that long equation. So, the way to do this before, you gotta actually understand what's happening. Girls, let's say, for example, after 2 hours, how far will Joe be from the town? How would you calculate if it was after 2 hours? I'm just dealing with numbers here.
Why are we doing that? Oh.
Yeah, 700. This is how much Joe's traveling for 1 hour. So after 2 hours, Joe is that much away from the town, correct? Then similarly, after 2 hours, how far will Nick be from the town? 680. That makes sense, yeah? Now let's generalize it. What if it was after t hours? That's right. So if it was t hours, similarly, it would be this. And it will be that, correct? So, using these two expressions, how do I find that distance? Pythagoras. That's right. Using Pythagoras, that's how you get that expression. Okay? So if you expand and simplify this, you'll get the long expression. Okay? That's what I wanted to show. These are your standard type of examples you will always get in your optimization problems. If you look at the HSC, it's somewhat similar but like harder version. So what I want you to do is spend this lesson to go through the whole exercise, and I think I might break it down and do HSC questions next lesson. How about that? Wait, that's not ours, is it?
No.
Yep. All right, that's it from me, girls. Thanks. Go through the exercise.